Here we go. Hey, I just wanted to echo everybody's thanks to everyone, and it's great to be here, seeing all the here in the Dominican Republic and seeing all our friends. So here's a talk. This came to me at the last NANOG because it was very interesting the way folks were approaching the IPv4 runout situation and what it all meant and what people were doing. And living inside a vendor, you kind of see a different perspective. And so all of this stuff kind of came together, and these are just kind of my observations on, I don't make this stuff up, I just observe it. And so let's see how this goes, and hopefully I'll have some time to hear what people are thinking about this. But I just call it the end of the world as we know it because my friend Hank Kilmer had rem.com, and so everything's rem with Hank. They wanted it, he didn't sell it. Okay, so this is the new internet architecture. Really. So here's my agenda on this. Okay, so what's the problem and what's it all about? And then what is the new architecture and which world is it that's coming to an end? And then I have a little bit of crystal ball stuff and then what I think is next. And then hopefully we'll Q&A a little bit. So, or just stop me if you want to. So before we dive into all of this, there's this certain amount of Grim Reaper stuff in here. And so, this guy actually has not fallen, notwithstanding reports to the contrary. But if, as my friend John Doyle at Caltech said, form enables function. And so you have to think about what we're building and what functionality we're going to get out of it. So what's the problem? So, and this was my observation from the last NANOG in the LA NANOG, which was really a great meeting, by the way. If you weren't there, it was really great. Watch it on online. Anyway, so the internet data plane's kind of under attack right now. Not concerted attack like you would think as a DOS or something like that, but basically intellectual attack due to the panic. There's just widespread panic out there due to the IPv4 runout. And when I wrote this, there were maybe 30/8s left. I don't know what the exact number is, but what is it, 25? Or, Mark, do you know? Some 25 or something like that. 28, okay, 25, 28, whatever. It's order of 30 in the free pool. Dual stack, the whole dual stack thing seems to have been abandoned. I'll talk a little bit more about that, but we'll see why I'm saying that in a second. And then there's all these varieties of NAT and things that may be considered NATs or beyond NAT are being proposed by kind of smart people. Or maybe the reason that they're proposing that is an oxymoron. I don't know, but something. But people who I thought were smart. And then the control plane's under some duress. Now this is a huge controversy about whether or not we can build a giant router, do we need a giant router, whatever. But there are operational practices and economic concerns that are putting stress on the control plane. How bad it is, we can debate that. But even with that, we haven't seen the widespread adoption of IPv6 yet, if that's indeed to happen. And then we have this RIR thing where, it's basically the, Vince Fuller's term for this is PI for all allocation strategy. So it really basically means that the control plane's in for some more rate times state behavior in the future if IPv6 really happens. And in addition to all of this stuff, deaggregation is on the rise, and I was just talking about Taroke about his study. He has a real nice study on this. And there's all kinds of reasons for this, as we all know. And then there's this other thing out there, right? What about the gray-black market for trading IPv4 addresses? What about that? What's that going to do? Well, when I wrote this, when I sent this to these guys last week, or a week and a half ago, or whatever it was sort of like hypothetical. Well, Aaron policy 2008-6 and the similar policy, right? It's sort of turning white as we're standing here. Oops. And so I just wanted to say that if you look at this kind of gives you a little bit of concern about the whole consensus-based self-governance model that's been so great to the internet, because if all of a sudden that gets taken away, at least in the address allocation piece of it, and it's actually living out in a market mechanism, what does that say? We need to think about that a little bit. And I'll just note on the control plane to finish up this a little bit that the IPv6 designers, as far as I can tell, I wasn't there. Some of you I know were there. never really successfully dealt or tried to deal or whatever with the control plane. So that's just hanging out there. So what's a concern? Here's my assertion. And there's right now, because of this panic-based response that we're seeing, there's really a lack of reasoned approach to the IPv4 runout problem. So this is the data plane problem I'm talking about, and the growth of routing state in the control plane. And in some ways, they're life-threatening to the internet, the end-to-end part of the internet that we all know and love. And that really is the innovation engine for all of this. And the end-to-end idea is so powerful, and that's what's at stake. But in this talk, I kind of really want to focus on the data plane because, you know, we've beaten the control plane to death and continue to do it on the RRG mailing list and every other place. It's almost too much to even talk about. So the panic du jour really is what's going on in the data plane, the IPv4 runout, and what it means. And that's what I want to talk about. But I just want to give a very brief idea of what's going on in the control plane first. So what's the issue there? I think we all know and love this graph, right? During the time I was on the IAB, we debated, I mean, we were intellectuals. It was unbelievable. We debated what curve best fit this for hours and weeks and months, you know? And I kept on saying, well, you know, I don't really care if it's super linear, whatever it is. It's up and to the right. That's all you got to know, you know? You can fit any other curve you want on there. It's up and to the right, right? Okay, well, maybe there's I don't know, can you see the pointer here? Can you guys see that? Well, right here was the tech crash, right, or the tech bubble implosion, right? And for a little bit, it wasn't up to the right, but you get the picture, and you certainly get the picture when you look at how much space you have left on your router and all of that kind of stuff, RIB, FIB, and all of that stuff, So I really thought, okay, this is really an academic exercise, up and to the right. That's all you got to know. So the whole solution to this whole thing, that's been the holy grail of all of this, is this locator ID split stuff. And it basically changes the semantics of the IP address. And the theory behind it is that you can't do good aggregation with IP addresses because the number spaces that you need for aggregating in the core are different than the ones that you need for identifying a host. And the IP address is trying to play both, so it doesn't serve either one very well. And so kind of the idea is if you had IPv6, what you could do is you got a lot of bits, right? So you could just let the red part of it be the locator piece of it, the routing piece of it, and the green part be the identifier piece of it. And, maybe we could do something there. Can't do that with IPv4, obviously, because in IPv4, you don't have enough bits, right? So what people are talking about doing is, well, right now it's ID and location. What if we just use that as a location routing thing to route around on, and then we just slapped another header on, and we'll call that, or we'll slap the other header on the front, and we'll call that the identifier, so we get some more bits by just encapsulation. Another great thing about the IP thing, right? You can just encapsulate it. Of course, there's MTU, but you can still do it. Okay, so how do you scale the control plane? Tons and tons of solutions, and they're almost all, with the notable exception of what these guys, I don't know if you ever heard about this, but there's a whole intellectual group of people who are doing something called compact routing, and they claim that scales. And it's not based on locator ID split. Everything else is. It's the grail. It's what we have intellectually around this. We don't have any other ideas right now. And I don't know if people know Noel Chiappa, but he's sort of the guru of this, and he was around back in the 90s when this was going on. Here's the pointer to his page. He's kind of reemerged recently to give us some wisdom on what he thinks on about all of these things. But end of the day, you got a blunt instrument. That you want to scale the control plane, one instrument. You got it. You got to do topological aggregation. That's all we got. So here's some things. GSE, another holy grail. 6.1 router, something that's been invented. I mean, there's get on the RRG list if you have a high pain threshold, and you can find all kinds of this stuff. Yeah. Okay, I said that. None of these things. All of these things are just kind of paper. They're IETF things, so they're paper stuff. But, we've been trying to implement Lisp, and we've been trying to deploy it so we can learn some lessons. And we've learned a ton of stuff, but none of this other stuff is gone. And I would really like to see somebody go off and implement this stuff so we could learn whether it works, what its properties are, and stuff like that. And if you want to learn a little bit more about Lisp, look on www.lisp4.net, or if we have 6 in here, you can look at www.lisp6.net. Those are out there. Yeah, as you might imagine, Lisp.net was taken. Okay, so let's get on to the thing I really want to talk about, which is the data plane. Okay, so what was our plan? We're going to scale the data plane, right? Because we know we want the internet to grow, and somehow we got to scale the data plane. So we had this idea. IPv6, good idea, lots of bits. So how to get there from here? Well, we had dual stack, right? I mean, does everybody know what dual stack meant? You just run IPv4 and IPv6 and together, and somehow magically one goes away at some point, right? So we had dual stack. It was a great idea. Just put two IP stacks in your box and your router and whatever. Great idea. So we had dual stack, and we also had dual stack, you know, and we had dual stack. I mean, we didn't have any other plan, right? This was the plan. Well, you know, it's an inherently flawed idea, right? I mean, unfortunately, really unfortunately, because, well, how does it work, right? I stick quad A records in the, you know, in the DNS, and I can signal that my host, you know, I look up your address and I can signal to you, hey, I got an interface that's IPv6 capable, why don't you use that? The unfortunate thing is, it doesn't tell me anything about the data path. So what is that going to do to me, right? I mean, especially if I'm taking calls in the call center about my customers. You know, consider what Vista was doing, right? What it would do was it would use the quad A record if it was there, have to time out because there was no path to the whatever, and then, you know, the phone would ring and you'd lose the revenue for the customer for the lifetime of the customer or whatever. So here's a beautiful graph by Jeff Houston that describes what was supposed to happen. So the IPv4 pool size is crashing away, the internet's growing, but we had this great technology called IPv6, and if we ran this dual stack thing, well, there'd be this crossover point right here, and, you know, all of a sudden, IPv4 would just start crashing away, and people just turn it off, and all of a sudden everything would be IPv6, right? I mean, it's a perfect idea, right? If it had worked. But what really happened was, another nice graph from Jeff, internet kept growing, IPv4 pool kept decreasing, continues to decrease, and IPv6 deployment did nothing. So now we're over here. I don't think you can really see this line, but we're over here. And so there's this big gap right here. And so what do, right? We're kind of, what do we do? So that's the panic, right? The size of this gap right here. And we want the network to continue to grow, obviously. All of us do. So what's the new data plane? What are we going to do about this? You know, people are still talking about dual stack. So I said earlier that it was effectively abandoned, right? Dual stack. And if you read this document, which was sort of the thing that a couple of the iStar people wrote as a, I don't know, document for one interim meeting they had. If you read that closely, you'll find out that basically the conclusion is dual stack was a great idea, but it didn't work. And, you know, if you couple that with what's called in that document disappointing IPv6 uptake. So what's happening? What's out there? So now I'm inside a vendor. I'm listening to what customers are saying. I'm looking at what people inside the vendor are trying to do. This is what I'm seeing. Carrier grade NAT. How many people have heard of this? How many people have heard of this a month ago? Yeah, well, okay. Now everybody knows what it is, right? And so basically what is it? It's a giant piece of big iron, right? And it's real hot and takes a lot of power. It's got a lot of state in it. And it's not really just NAT. It's NAT PT because, protocol translation, right? Because dual stack didn't work. So how am I going to talk to the rest of the world if I have V6 or V4 on either side? I need NAT PT, protocol translation somewhere. So there's double or triple NATs going on, right? There's this other idea called A plus P, address plus port. It's kind of a crazy idea, I thought. But basically the idea was, all right, so I'm a consumer. I don't usually use 65,000 TCP connections, so maybe I can steal some bits from the port and make a bigger address out of it. There's dual stack light. That comes down to CGN plus some tunneling. People have talked about IPv6 edge with IPv4 core, 6 to 6 over 4. Does that really work? I mean, is that useful? You know, Metcalfe's law, stuff like that? How about IPv6.google.com? Anybody seen this? Why didn't they put quad A records in google.com in the beginning? Well, because dual stack didn't work. That's the most obvious evidence that dual stack didn't work. Now they're giving you this Google over IPv6, which is sort of a way of saying, I'll give you a DNS view, but you take responsibility if you don't have a path. Go, Joel.
Google will serve you quad A records if you come from a destination that they have deemed as V6 capable.
Yeah, that's Google over IPv6. And that's just saying, you guys take, I'll give you a view, And that view is saying, you guys it's your responsibility now.
Right, but I mean, they're engaged in a magic DNS load balancing exercise, and which records they give you is a property of where you come from, and that actually doesn't change whether you're on V4 or V6.
Okay, well, John.
Hey, Dave. So I don't know if you can say that dual stack is effectively abandoned. I mean, it's still a huge part of what I got going on. You know what I mean?
Yeah. People are doing it. I'm not saying people aren't doing it. I'm just saying that from the perspective of what's being deployed right now and how people are trying to solve this problem and what's been written in the IETF, it functionally. So, well taken though. Okay, so can you do IPv4 edge with IPv6 core, 4.4 over 6? Well, if you could do that, you could just do 6.6 over 6. So you don't have an IPv6 core, which is was part of the problem that I think it must have been the case that the designers of dual stack thought that, oh, well, I'll get an IPv6 core and I'll be able to transit this stuff. But does this work? Well, not really. Now you're seeing stuff like NAT66 emerge. Okay, so this is 6-to-6 NAT. And what happened to IPv6 is great, we don't need NAT anymore. Well, now we have NAT66. And I didn't say 666, which is just 6-to-6 over 6. I mean, it goes on, okay? It goes on. What can I say? This is just a data point for you all. The Behave Working Group in the IETF has now kind of found the role that they are responsible for sort of standardizing the NAT behavior. So IETF never standardized NAT, which is part of the reason it's difficult. Well, the Behave Working Group met 7 times at the last IETF in 2 interims. That tells you something. I never heard of a working group meeting 7 times in an IETF. So, okay, what does it all mean? This carrier-grade NAT stuff's going to get deployed. So, there's a synergy, right? The synergy is, and I don't know if you can have a bad synergy. I think synergy means good combination of things or something. But the synergy is, it's big iron, right? So vendors like to make big iron. And if you are a service provider and you need IP address space, it has a good property, right? You can unilaterally deploy it and it frees you up from the IRR, from any relationship with the IRR, because now, you're kind of manufacturing or multiplexing more globally unique addresses on one single, on a bunch of different addresses. So there's kind of a, everybody's kind of liking it. The only people who aren't liking it are the ops people who are going to have to actually run this stuff. And probably some of the people who, some of the consumers of consumer connectivity that might realize that there's implications to this. Okay, so carrier-grade NAT, it's in your future. Dual stack light, yeah, that's going to be standardized too, because it was just recently added to the software working group as a charter item. So you're going to get a standard that's dual stack light, and vendors are going to go implement it if somebody checks it on an RFP. So that's going to be in your future. I used to think that A plus P was going to A plus P was all about, we hate NAT, and so we're going to do something different. And so I thought it might be picked up, but there was some indication at the last IETF that it was such a wacky idea that maybe people are going to give up on it. There's some potential for IPv6 to be confined to the edge for all the reasons we're just talking about. And, I kind of wonder, would this be fatal for IPv6? Could it survive as an edge technology? And, if you have an IPv6 edge with an IPv4 core, does it really solve a problem? I'm not sure what problem it says. I still got, who do I talk to? Metcalfe's law or whatever. And then there's all this second system syndrome stuff with IPv6 that, you're kind of a little worried about. So what do we get left with? Okay, so live with it, you're gonna see it. Now this is the question I have for everybody right here. So if I have CGN, if I have this technology that says to you guys, hey, you know what? You don't need to go and get more addresses. You don't need to coordinate with an RIRs. You don't need to coordinate with anybody. I'll just give you a big piece of iron and you're done, right? Mod, some stuff we'll just talk about. What does that mean for IPv6? We've already had so much difficulty getting it deployed. Now I'm giving you another technology, not me. We're giving you another technology. Okay. Well, now we're giving you another technology that says you don't need IPv6. What's going on? I mean, what's going to happen? So, I'll just give you a view from inside a vendor. A vendor goes, hey, we're going to do everything. We did OSPF, we did ISIS, we do everything, right? Well, the OSPF and ISIS were somewhat independent, right? You want a link state routing protocol, you take the one you like, right? Here, these things interact strongly, and so the question is, if you deploy CGN, what does that do to IPv6? They're not independent is the issue. So what does it all mean? Well, it means escalating costs for everyone, right? At the very least, the carrier is now going to, the service provider is now going to bear a lot of support and customization costs on per customer basis because, if you kind of look at this carrier-grade NAT thing closely, what you find out is that it replicates that. So I got my little Netgear NAT box on the other side of my cable modem, right? There's a bunch of state in there about the port mappings and all that stuff. That stuff goes and gets replicated back out in the carrier-grade NAT. So now somebody's going to have to manage that state. Escalating complexity in applications, and they're going to be more fragile, right? And reduce flexibility, increased risk of failure. All this stuff goes along with having a bunch of states scattered around. And then this is the worst part of it. End-to-end is going to be extremely fragile in this environment if it works at all. John?
How about, just to point out the obvious, what about the impact of the subscriber?
I haven't gotten there yet.
Okay.
Hey, look, I feel like the Grim Reaper, man.
I know, I'm with you. It's just, this is a hot topic, right? So.
Yeah, but, like I said, I'm not making this up. These are just my observations. Or maybe I am making it up. I don't know. So somebody gets up they had this really interesting session at the last NANOG, if you weren't there. It was called What Would John Do? And the hypothesis was, Postel was the, guru of every kind of number and address space allocation, and what would have he done? And somebody got up at the end of this and said, well, what's really wrong with NAT? What's the problem? And this is what Van said. I looked up because he mentioned my name. That's why I know. So, it's like, Van? Well, okay, what'd I do? I thought I was in trouble or something. So he goes, NAT couples, this is what he said to this guy. It was a really good question, it's like you get asked, it's a reasonable question. He said NAT couples the inside address and port to the outside address and port in a many-to-one relationship, right? And we know that. And he goes, well, this is the kind of coupling that causes complexity and hence fragility, right? And then he started talking about this, but he talked about this RFC 3439 that I wrote. It was actually an internal document I wrote when I was at Sprint because I couldn't believe how complicated the network was that they were building. And I was trying to figure out why. And then Randy was at AT&T at the time, and I was kind of sharing this with him, and he couldn't use an internal Sprint document at AT&T, surprisingly. And so we turned it into an RFC. There's another thing going on here. This is going to induce some kind of unwanted structure, or well, maybe depends on who you are. It will induce a structure on the SP industry, and it's sort of the same way that giant routing tables induce a structure. If you have to have a giant router just to play on the DFC, that's going to limit who and what kind of people play, right? So if you now have another device that's a giant, expensive, hot, power-sucking alien device that you have to play, that's going to induce a structure on the industry. Have we thought about it? I don't think so. The other question is, okay, so maybe this is all fine. Maybe it's not all fine. It doesn't seem so fine to me, but some people think it's okay. But then if we want to have a solution to the problem that I'm kind of trying to outline here, where will we look for solutions? That's a meta problem on top of all of this. And if you think it's the IETF or the RRG, have you noticed the last 20 years? This stuff's been around for 20 years, and we're going backwards, not forwards right now. So I'm not sure. So here's my picture worth 1,000 words. Maybe you should stop the train, or get some tracks before you run off them, or whatever the right metaphor is. But wow, it's a train wreck out there. So what's next? Well, the sad thing is if this happens for the SPs, the internet's just going to cost more to operate and to deploy. If these large state-bearing devices and they're big, these things are going to be big. There's going to, I've heard numbers like million subscribers per CGN. If you can imagine the amount of state that's going to be in that. For users, so I think John asked this, for users, the internet's going to be way less reliable and more expensive. Well, the cost of running it's going to have to be transferred to somebody, and it's going to be less reliable because there's more state, more complexity, and all of that stuff. More balkanized because, wow, you know what? CGN's auto walled garden. It's like you don't have to worry about whether or not I'm going to rate limit bad traffic. It just doesn't work anymore, so it gets rate limited to 0. It's really nice. Not only that, so don't worry about BitTorrent. It doesn't work. And net neutrality, by the way, you can't implement it anymore, right? So look at the number of problems this thing solves. It's great. So we're all out here debating, you get out, there's people who think IPv6 is the answer. There's people who think it will never be the answer. The anti-IPv6 person, Vince Fuller or whoever, never, can't be. Some people are out there evangelizing. The question is IPv4 versus IPv6? No. Train's left on that too. This is the question. Oh yeah. Okay, I had this too. What's the value proposition? People are going, what's the value proposition for IPv6? What's the Metcalfe's law? What's all this stuff? It's not the problem anymore. Here's the problem in my mind. How do we get from this place where we're going to wind up? Everything's heavily netted, NatPT everywhere. That's the world. All of a sudden, we got to that world. How do we get from there back to an internet that's more like the one that we know and love, the innovation engine, the end-to-end internet? How do we solve that problem? Because that's the real problem now, not IPv6 or IPv4. That's in the past.
One way is not to go there.
Yeah, but as you know, I think it's locked. I don't know. I think it's inevitable at this point. So there's more questions than answers in this.
But
John?
Dave, even if it's inevitable, isn't our job to make sure that if it happens, we limit the amount of time? Like, instead of making it forever technology, if we need a crutch to get from point A to point B, maybe CGNs are the way to go, right? And I don't think anybody here is really in love with the idea.
I don't know. Are there any vendors out there? I mean, come on. There are people in love with the idea.
Yeah, but dude, I mean,
not me, and not you. But
if you put, you might love it on one side, but if it adversely impacts the subscriber experience, then there's a cause and effect there, right?
Yeah, I'm with you, man. I mean, don't shoot the messenger.
I did. 2 points. Earlier when you said that the...
Sorry, excuse me, I can't hear you.
Sorry, move closer to me.
Could you state your name too? I'm sorry, I don't.
I'm Rocco from Equinix. 2 points. Quite earlier in your presentation mentioned that the transfer policy hasn't been accepted yet in RIPE. It has since December 16, but that's beside the point.
Yeah.
What I think, when you're in your response to your final question, I think that we all feel no answer to this one, and is we're going to add yet more complexity. And I think that since the ISPs will move to NetPT or something like that, you'll see end users go and dig tunnels and VPNs across it to do whatever they want to do.
Yeah. Could be. Well, one of the things about it is that if you have this environment, this carrier-grade NAT thing, what's going to happen is the web will probably still work, right, for most parts, right? So the question is how many, if I'm an SP and all of my subscribers are just basically surfing the web, they probably wouldn't even notice, right? So am I damaged in that way? Well, the people who are the innovators are, but maybe not and that's the damage that's really being done by this. So it's really, this whole thing is about more questions than answers, right? So I was trying to figure out, well, what would I do if I was the czar? First thing I'd do is I'd really, and this kind of goes to John's thing, is what can we do to, to mitigate the effect of all of this? If indeed, the crystal ball is not as cloudy as maybe it seems. And how will we do this? Because one thing I wanted to mention, John, is that, the internet has this nasty habit of once something is deployed, it's pretty hard to dislodge it. It really is. We need some serious research into, what kind of internet scale data and control planes will work. We're really, we work on things, RRG, I don't know, it's been a little bit disappointing. I don't think it's been as fast or nimble as I would have liked it to have been, but maybe that's an aspect of the process. And we're doing, we're trying different things, but we need larger scale efforts. And, it's a multidisciplinary thing too. I think right now on the RRG list, there's a discussion going on about, the economics of different kinds of, mapping systems, whatever those are. And, we've done this before in the internet space, DNS and this sort of stuff, but we need to get a multidisciplinary approach to this because there's just so many variables and so many factors, economic, technology, sociological, all of this kind of stuff. And we need, and it's not going to happen in a casual manner. So we need to think about it as a community. That's what I got. Anybody else? Going? Bill.
Thanks for bringing this up. It just strikes me that we consistently go down the path of least resistance. So whatever's easiest to do, we tend to do that. And that ended up being just a dead easy thing to do, right? You pop a box and all of a sudden you get all these machines at your home connected up over a single IP. Great, it works. It seems like if you keep on going in that direction, it's going to take a mighty, mighty pain point in order to get rid of that, dislodge that technology. A pain point being that, well, it just doesn't work anymore.
Right.
And maybe at that point, something new, something different is going to have to draw people enough. They'll be sweet enough to make them want to do, yes, maybe a little bit of the old thing that doesn't quite work, but also sign up to this new thing. Have you considered that trajectory of future?
Yeah, I actually think that's how it's going to unwind. Basically, stuff will stop working, and somebody will come along and they'll put up, what is it, IPv70 or whatever it is, and they'll start offering services that start looking like the internet does now, and people go, hey, that's pretty cool. Why didn't we do that before, right? So I agree with you.
It might be proprietary network.
Yeah, that would be worse, but yeah, maybe.
Brendan Ross with Diacom. Just as a little bit of support, I think, for what you're saying, we work with a lot of operators in the developing world, so the information has not necessarily gotten to them maybe as clearly as your typical NANOG attendee. And I find extremely often finding myself explaining why they don't really need to NAT their entire network. And we're just talking V4 today. Why they don't really need to NAT their entire network. And yes, addresses are still available, even though there's, we've done apparently a really great job of making them all believe that there are no more V4 addresses already, and just assume you have to build your entire operator's network with NAT, like the whole core.
Yeah.
So I'm sure others have run into that too, but
Yeah.
it's something I've been dealing with a lot in the last year. So.
Yeah. Yeah, well, so maybe the answer is, maybe one of the answers to this is, well, there's going to be a market for IPv4, and, you have enough money, you can probably get some, right? But that'll hose the control plane, so, because people will deaggregate then, and, that's not a good answer, right? I mean, we need something more architectural than, as Bill was pointing out, than the path of least resistance. Let me go to John, and then...
This will be my last one, Dave. Sorry to...
No, there's no quota.
So the only thing because we all care, the internet's near and dear to all of us, right? So in my mind, to kind of help minimize some of the pain that we're kind of saying out loud we think is going to be coming our way in the not distant future, it seems to me one of the things that we can do is, particularly the folks in this room, is to start doing the things that need to happen to encourage V6, right? If you have your own content, services, making those available, right, like we do, making those available over IPv6, right? Start working things through, because there's still a painful lack of that in the big I internet, right?
Yeah, I gotta just give one. I'll go next, Joel. But somebody from Comcast, I forgot who it was, but this guy who was, we were sitting there talking about this, and the guy says to me, he turns to me, and I'm sorry I forgot his name, but he turns to me and he says, well, I'm a provisioning engineer. I sit around all day, and what I do is I provision CMTSs, right? What he does, right? And he goes, have you ever noticed that there's no letters and no colon on a numeric keyboard? It's like, even at that level, right? Even at that level, the person has to change their behavior to go to IPv6. And when you think about from that level to the back end systems, routing, all of this stuff, the distance is far, and part of the thing that makes CGN kind of inevitable is that we don't have enough time, in theory, to get that distance before IPv4 run out, right?
I've run that race. I can see the finish line, right? I'm getting to a place in the not distant future where I hope to be able to come here one day and say, hey, you know what? You can check Comcast.net over IPv6.
Yep.
Right.
I know you're working hard.
Yeah. So.
Joel.
Well, so I think one of the other observations that goes along with the discussion of deaggregation is that property is inevitable as far as I'm concerned. I mean, there's no avoiding that, regardless of what technology we deploy, and you know, even if it's V6, we get it there. So I mean that also, you know, obviously drives the consumption of other hot boxes in the network that we all know and love. But we already have a model for that, and I mean, what we do see now is you run out of V4 addresses as well. That's one impediment to the growth of the routing table, and of course, the deaggregation one moves on from there. So,
right.
I mean, clearly we've got to be on schedule if we're going to have 500,000 routes in our DFC table in a year. So,
Right. Well said.
Wes Hardiker, Sparta. You know, I take a little bit of issue with your stating that at some point in the future things are going to be broken, and that's going to be the point where, you know, V6 is going to suddenly be deployed and it's going to be...
I didn't say that.
Well, you sort of alluded to the point that at some point things will be fixed. But
I didn't say they'd be. Let me make a point.
Okay.
I didn't say they'd be. I explicitly did not say they'd be fixed by V6. Explicitly did not say that.
Fair enough, fair enough. But my point is, we don't live in a world where it's black and white, unfortunately. And to the end user, my parents believe that the internet is slow. And if they have to go through 15 different NAT boxes and they don't understand that it's going from, you know, from one mechanism to another, and it's possibly going through multiple hops, you know, carrier grade or not, unfortunately it's still going to work. And I say unfortunately because there's very little financial incentive to most people to fix things that are sort of in the gray area. You know, if things are broken, hacks get deployed and they get fixed. But unfortunately, the hacks tend to slow things down a little bit, and that, unfortunately, is a hack. And it works. And it's a good thing that it works, because it does fix things. But, you know, we're not going to get to the point where, unfortunately, things are going to stop working to the point where it's going to be an incentive to fix it. Unfortunately, what we have to do is the right thing. You know, if we had, and there's enough people in this room, I know, that are starting to do the right thing and actually making it easy to deploy and deploying it on the service end, which is going to be a critical point, and, you know, deploying it in base operating systems turned on and all those kind of things that will actually make 6-to-6 end-to-end work in a positive fashion. Unfortunately, the financial incentive to do the right thing is low because we're getting grayer, not more black.
Yeah, and that's kind of part of what I was trying to drive at when I was saying the whole problem is multidisciplinary, right? It's not just a technology problem. So your point's well taken.
Yeah. Just to support that again, that's exactly what I run into. Is they're like, well, we're going to do NAT. Well, why would you do NAT? Well, we can't get any addresses. Well, why wouldn't we do NAT? Well, I try to explain. Well, there's these applications that are end to end, but they don't get that. They're like, well, can I surf the web? Yeah.
Okay, done, right?
Does VoIP work? Well, sort of. We can kind of make it work. Does video work? Well, yeah, unless you want to like send your own video directly to your neighbor. Oh, well, we'll never do that. It'll always go through the server.
Yeah.
Okay, but you're breaking things, but it's really hard to explain to someone with a basic level of networking knowledge, but not that kind of insight. So
well, you know, we don't want people who aren't networking people to have to know that stuff, though,
yeah,
right?
that
you
too.
know,
Exactly.
You know?
Exactly.
You know, I mean, if you have a technology where you have to be a rocket scientist to use it, and your grandma's not one, then, you know, Dino.
So we have to be really careful when we say NAT works. We know NAT works in a class of boxes that are Linksys, Netgear, for a very small set of addresses in a home residence. We have no idea if NAT can work between two service providers. Being an implementer and trying to get traceroute, just one single, very rudimentary application to work through NAT is going to be huge. You know how much intermediate state will have to be done to get traceroute to work through a NAT? Because ICMP does not return the entire packet back to you, any tunneling that you do will lose the original source. Traceroute by itself will break, let alone all the applications that you alluded to.
Yeah, let me just, we gotta shut down. I just want to say one more thing on that, because somebody said something about VoIP, right? Who said that? Okay, so yeah, we have these great technologies, about 1,000 of them, stun, ice, turn, all this stuff, firewall, traversal junk. Do you think that all of the million subscribers, like say in John's network, John's going to want, now he has a carrier grade NAT that's serving, what, million subscribers? He's going to let people connect to that thing and stun, ice, turn to it? I don't think so. You know, I mean, I don't think that, and even if he did, could you build an engine that would scale to that? I don't think so, not right now. So, okay, that's all. Thanks.